Hi everyone, and welcome back to another Calculus First Derivative video explanation with Mr. Simons. And in this video we're going to be learning how to determine the second derivative or concavity, right? So in short, determining the second derivative, you already know how to find f prime x. Now we have to find f double prime x if fx equal 2x cubed. So first derivative, first time I'm going to say 3 times 2, 3 minus 1, and that gives me then 6x squared. For the second derivative, I'm going to follow the same process, but I'm doing it twice now. 2 times 6, 2 minus 1, so second derivative then becomes 12x. When they say second derivative, it just means you derive for second time. Now, under cubic functions, we will do this more in detail, but I'll give you a brief explanation, because sometimes, as I said, this question appears under question 8, under the rules of differentiation and first principle problems. So the point of the second derivative is also known as the point of inflection on a cubic graph, and that point is where the graph changes concavity. So what we technically mean is it changes from being concave up to concave down. Say there, deeper explanation will be given with drawings under cubic function, right? So determine the interval on which f is concave up. So once I hear the word concave, up or down or concavity, I need to find the second derivative. So given to me, f of x is x cubed minus x squared plus 2x minus half. Derive the first time, 3 times 1 is 3. 3 minus 1 gives me 2. 2 times 1 is 2. 2 minus 1 would give me 1. 1 times 2 simply stays 2 and x falls away. And constant becomes 0. Now for second derivative, 2 times 3 would give me 6. 2 minus 1 gives me 1. 1 times negative 2 then becomes negative 2. Alright? Now, just a note, the a value of the cubic function is positive. Therefore, f is concave up when the second derivative is greater than 0. So there the a value is positive, not the red. The a value there is positive. So second derivative would then be greater than 0 for it to be concave up and less than 0 to be concave down. So they want concave up, so I'm going to say 6x minus 2 must be greater than 0. If I take negative 2 across, it becomes positive 2. And I divide by the value in front of x, so it becomes 2 over 6, which then simplifies to 1 over 3. So therefore, the x value must be bigger than 1 over 3 for this graph to be concave up. Right? Let's look at another problem. Determine the interval on which f is concave up. So they've given me y equal minus 3x cubed minus 4x plus 5. So first derivative, 3 times negative 3 gives me negative 9. 3 minus 1 is 2. 1 times negative 4 gives me negative 4. 1 minus 1 makes it x to the power 0, so the x falls away. And 5, I assume you know by now, first derivative of a constant is 0. So I differentiated y with respect to x. Now I'm differentiating for the second time y with respect to x. So 2 times negative 9 gives me negative 18. 2 minus 1 gives me 1. So if we use this notation, that is how I would write second derivative. No? Again, note the a value is negative, so that there is negative there. Therefore, f is now concave up when the second derivative is less than 0. So if you go back to the previous, if it's positive, then concave up greater than 0. When it's negative, concave up less than 0. So minus 18x less than 0. If I divide by a negative, the inequality sign changes. Right, 0 divided by negative 18 becomes 0, but that changes from less than to greater than. So x then is greater than 0. Right, so very important, division by negative changes direction of the inequality sign. Right, let's look at the last problem. Determine the second derivative of x, f double prime x, if fx equal to the fourth root of x to the power 6. Right, so written as a rational exponent. The inside exponent go on top, the outside at the bottom. That becomes 6 over 4. Right, which technically is 3 over 2 if we simplify. So this times 1 would become 3 over 2. 6 over 4 minus 1. Right, which then gives me 3 over 2, and there that would be 4 over 4. So if I subtract 6 over 4 minus 2 over 4 gives me 2 over 4, which simply becomes half. For the second derivative, it's going to be half times the 3 over 2. So 1 times 3 gives me 3, 2 times 2 gives me 4, but half minus 1 then becomes negative half. Right, thank you. Make sure you watch all the variations. God bless. Bye.